Okay, yesterday we talked about translations, and today we're going to talk about reflections. So let's see what we know. When you reflect a figure across a line, each point of the figure maps to another point the same distance from the line, but on the other side of the line. So the orientation of the figure reverses. So we're going to look at some pictures and so on in a few minutes. And some of you might remember this from middle school. A reflection across a line, and we're just going to call that line M. And M is going to be called the line of reflection. This is a type of transformation. So yesterday I talked about transformations, and the first transformation we talked about was a translation. So the second transformation we're going to talk about is a reflection. So what do I know about these? If a point is on the line of reflection, then its pre-image and image are the same because that point's not going to move. If the point is not on the line, then that line M is going to be a perpendicular bisector of the line that would be made if you connected the pre-image point to its image point. So how do we write the reflection across a line M that takes P to P prime? We would say capital R. M stands for the line that is the line of reflection. Then the pre-image is P and the image is P prime. So let's say I have triangle ABC, and I am going to reflect triangle ABC over line M. When I do that, since A is on the line, A and A prime are exactly the same point. C becomes C prime and B becomes B prime. So a line drawn from B to B prime would be the perpendicular bisector of that line M. So this is just a diagram explaining what I talked about up here. Okay, next page. Let's talk about the properties of reflections. Reflections preserve distance, and reflection preserve angle measure. Reflections map each point of the pre-image to one and only one point of its image. So are reflections rigid motion? Yes, they are, because it preserves distance and it preserves angle measure. And they're going to also be isometric because it preserves the distance, which is the requirement of the isometric. So let's look at the diagram here. In this diagram, we see that the reflection over this line T of G is itself. We also see that the reflection over the line T of D is itself. So since they are on the line of the reflection, they do not change. Now, on this line, it tells us that the reflection of H is going to give me J. So we're going to use the properties of reflections, which are given up here, to describe how you know that triangle GHI is an isosceles triangle. And I think that's supposed to be GHJ. I think I misread that. So let's fix that to GHJ. Alrighty, so that's better. All right, since the reflection over T of G is itself, so when I reflect it, G stays G. And since the reflection over T of H becomes J, and reflections preserve distance, then if I do the reflection over T of GH, this one, it would become GJ. So I would know that GH was equal to GJ. Let's go ahead and make this there we go. All right, so by definition, triangle GHJ would then be an isosceles triangle. And that's an example of probably one of the problems you will be doing for homework. Okay, another example. Let's say that point P has coordinates 3, 4. So here is point P with 3, 4. What are the coordinates of P once I do the reflection over the line y equals 1? So let me draw the line here, y equals 1. And all you do is count how many units do I go from the line of reflection to get to P. That's the same amount that I will move from the line of reflection to get to P prime. And that's how you figure it out. So it's really simple. Same thing as when you graph a triangle. So let's say I have triangle ABC, which is going to be this triangle here, ABC. So that is triangle ABC. A is at -3, 4, B is at 0, 1, C is at 4, 2. Now I'm going to graph and label the reflection over the y-axis of this triangle. So here's the y-axis. If A is 3 units from the y-axis, then I go 3 units from the y-axis this way to get A prime. If B is on the y-axis, B does not move. If C is 4 units to the right of the y-axis, then C prime will be 4 units to the left of the y-axis, and this would give me A prime, B prime, C prime. So reflections are relatively easy. If you have any questions, you can send me questions on Remind, or you can ask questions on Google Classroom, depending on what your teacher has. You can watch the video again if you need to and slow it down and look at the examples better. But these are the notes for section 9.2, Titan Learning Days 23 and 24. Have a good day.